Hi all, this is Dr. Shanthi, Professor, EC Department, RMK College of Engineering and Technology. In this presentation, we are going to see the various bacterial attacks in body area networks. Now, we know what happens if there are interferences. What happens is there are threat to the body sensor networks. What happens is the body sensor network will fail. What are the threats to the body sensor networks? You have two types of analogy. One is bacterial analogy and the other one is virus analogy. Now, compromised nodes, we give it a bacteria analogy. These are like bacteria attacking network integrity by releasing harmful actions. The next one is malicious programs. It is virus analogy. Here what happens is data packets or malicious programs infiltrate and infect sensor nodes, damaging the sensor network. Now we are going to see 13 possible bacterial attacks. The first bacterial attack is going to be called as jamming. Now what is jamming is, here you have a sensor node A, you have one another sensor node B. Now by the process of jamming, or what is jamming is, it's a low level technique to disrupt the service of wireless network is through jamming the frequency band of wireless devices. See here there is an attacker. What it does is it jams the frequency bands of the wireless devices. However, in the case of body sensor networks, due to unambiguous ubiquitous nature of the application and short range radio design, jamming can only cause localized interruption to the service of the system. And one more thing is, if frequency hopping schemes are used, such as direct sequence spread spectrum, then the effect of jamming is minimal. The second bacterial attack is going to be called as collusion. Similar to physical layer attack, attackers can jam the data transmission path by corrupting the packets at the link layer. See here, you have a sensor node A, you have a sensor node B. Now what the attacker does is, it disrupts the checksum of a packet, causing retransmission, thus leading to collisions in the network. So what it does is, the attacker, it corrupts the packets. For example, it varies or it disrupts the checksum of a packet, causing retransmission. The next type of attack is going to be called as exhaustion and interrogation. Now what happens here is, now for critical messages, sensor node will retransmit the message repeatedly until it reaches the sink, and if the message itself or acknowledgement itself is corrupted, actually it keeps retransmitting until the message reaches the receiver. Through corrupting the acknowledgement messages or sending false acknowledgement messages, an attacker can cause endless retransmission and eventually bring the network down. See, for example, you have a sensor node A, you have a sensor node B, you have a sensor node C. Now what this attacker does is, it sends a sensor, or it corrupts the acknowledgement message. Right now, for example, if a sensor node A transmits and if sensor node B receives it and sends an acknowledgement message, this attacker, it corrupts the acknowledgement message. So what happens is, sender A keeps on retransmitting the messages. So what happens is, there are a number of power consuming commands such as network initialization and time synchronization. If an attacker continuously broadcasts those commands, the battery power of the sensors will soon be exhausted. This repeated solicitation of energy draining responses is called interrogation. Now the fourth bacterial attack is going to be called as selective forwarding. In a multi-hop network, messages are expected to be forwarded to the sink through multiple hops. In a selective forwarding attack, what happens is a compromised node may selectively reject certain messages or may randomly drop messages, thus causing data loss and triggering costly network recovery mechanisms. Now, see here, I have sensor node A, I have sensor node B. Now, sensor node A, it transmits messages. Now I have an attacker in the middle. What it does is it does not transmit all the messages that are coming from sensor node A. It drops, if I say for example, see in the figure, message 1 is dropped, message 3 is dropped. So it selectively rejects certain messages, creating data loss. So this is going to be called as selective forwarding. And the next one is going to be called as sinkhole attack. In a sinkhole attack, an attacker attempts to lure the network traffic through a compromised node and does this by making the compromised node look especially attractive with respect to the routing algorithm. Once a sinkhole is created, the network is open to other attacks such as selective forwarding or eavesdropping. Now, what is the meaning of it is, see here, sensor node A. Now, that is the next node in the, that is in the routing table. The path has to be to either sensor node B or right, or in the same way sensor node D to sensor node C or sensor node C to sensor node D. Now the attacker will act as a sinkhole, so that in the routing table for the next location for sensor node A is created, is taken by the attacker. So and what happens here is a compromised node is being created, or a routing algorithm is selecting the attacker as the next thing in the routing. So this is going to be called as sinkhole attack, which results in selective forwarding or eavesdropping, resulting in data loss.